Welcome friends to the another video on the basic electrical engineering. Here we are going to discuss about the node and mesh analysis, some numericals. We will try to solve one numerical both using the node analysis as well as the mesh analysis. So let us take this example here, and what we can see in this example like this, and this is having 8 ohm, 2 ohm and 4 ohm resistor with having 5 ampere current source, and here 10 ampere downward current source, and V1 and V2 node voltages. Now our objective is to use the node analysis first, and we will verify the same using the mesh analysis. And if we use a node analysis, then how to approach? You can take the equation for node 1 and you can apply here KCL and KCL and Ohm's law for the node analysis. And when you write for the equation for node 1, you can from the node 1 you can think about all the current is going out. So there are 4 branches or 4 elements connected with node 1, and assuming that all the currents are going out, you can do it. Now the hurdles over here is, here you know that in this direction the current is 5 ampere, so this current is minus of 5 ampere, it is known. Here you can find the current, before that you need to have a reference. Okay, one node is taken as a reference over here. Now this current is going down, you can easily find like V1 by 2 as the current which is moving downward. And the current which is going in this direction up to this node, you can easily write V1 minus V2 by 8. So you have got 1 over there, and here V1 by 2, another is minus 5 ampere. But here you do not have any resistance, so how do you find the current over here? So there are many ways in which you can solve by using supernode and other things, but let us go for a simple way. Let us say that the current over here is Ix. So Ix is a current which I do not know, and just let us say this Ix is a current moving in this direction. In this wire it is moving in this direction. That is a Ix, a fixed current. So as this is a voltage source, for a time being we will just say that okay, this is the current Ix which is moving from node 1 to node 2. Similarly, we can write for the node 2 equation for node 2 we can write. Let us start writing, and just before that, just node 2, also there are like all the currents are going out, and here only thing is that here if I consider the current going out, the Ix is the source. I have assumed that this Ix is minus sign. So let us write this equation again here, that let us write the equation for node 1, then we will write the equation for node 2. So equation for node 1, applying KCL, you can write by applying KCL, Kirchhoff's current law, and Ohm's law. And in some cases you are not using Ohm's law because you're just getting the answer directly. So you can write here let us begin from 1, 2, 3 and 4. 1, 2 and 3 and 4. Let us write here like this. If V1 is a current which is going in this direction, so this will be, so writing like this, we can write here it is equals to minus of 5 for 1, because current is going here upward and we are assuming all the currents are coming out. So minus of 5 plus V1 by 2 in this direction, and here is our reference node. So that's why the current which is going here is V1 by 2. Then we have here the current is, we are assuming here is Ix. Okay, so Ix is plus because we are assuming the direction here Ix to be in this direction. This is Ix assumed, and another current is which is going in upward is V1 minus, so we will write here V1 minus V2 by 8. That is 4 equation. This is equation equals to 0. So this is equation 1. We can rewrite this equation, but let us first write down for equation for node 1. Then let us write, you can write here again same in the same structure like node 2, applying KCL and Ohm's law. and let us write the equation for node 2. In node 2 also there are the currents which is going out is the 4 currents are, let us assume, to be going out. So we will just going to add it. Let us begin from here. So we are assuming here it is going out. So this current is Ix is coming in. So I need to write here minus of Ix. Here it is going down. So V2 by 4. So let us write here V2 by 4. And again here it is going in this direction, but the current is 10 ampere already given, so I just need to write 10 here, and here it is V2 minus of V1 because we are assuming the current is coming out of the node 2. So this is equals to V2 minus V1 by 8 is equals to 0. So we get two equations now done. So what we are going to do is we are going to add these two equations and write down what is the value after that. So I just write down that what is the value of this first equation in this form, like V1 we can take the coefficient 1 by 2, 1 by 8 here common, and again here V2 coefficient is minus 1 by 8 is equal to this 5 will go on this side, right hand side it is 5 minus of Ix. So this is 1. This equation can be rewritten like this. And the equation 2 also can be rewritten. It is usual habit to first write the V1 coefficient, that is minus 1 by 8, plus V2 this 1 by 4 this coefficient, and 1 by 8 the coefficient of V2 here is equal to Ix will go on right hand side, it is minus, so it will be plus Ix, and this term will be minus 10. So what our objective is to add 1 and 2, these two equations we add. So what is the final ending? What is that? This Ix and Ix term will cancel out, and we will lead out to some value of V1 plus V2 and is equal to some constant K. So if I go on solving that, so what we are going to get is, finally we are going to get is after doing the solving these two, we are going to find this value as 2V1 plus V2 is equals to minus of 20. So this is what we are going to get after this. So let us go to the another screen here. So what we get here is 2V1 plus V2 is equals to minus of 20. So now this is equation number 3. Now I need, because I have defined here that this is the current Ix which is going from from 1 to 2, and this Ix is what then we need to find. So this Ix, to find it out, this Ix, I'm not getting this value of Ix because there is no resistance. So why don't we just subtract this node potential? Can I write like V2 minus V1, because 2 volt is between V2 and V1, so V2 minus V1 is equal to 2. So we get another equation, the equation 4, from this, that V2 minus V1 is equal to 2. We are not using here any Ohm's law, just we are, because we know the potential of V2 and V1, we are writing it as V2 and V1, we just make it V2 minus V1, and because plus sign is on this side, that's why it is V2 minus V1 is equal to 2. So if I add these two, like if I do the solution, solve this equation 3 and 4, what I am going to get is I am going to get V1 and V2. So V2 I am going to get first as minus 5.334 volts, and V1 I am going to get 7.33 volts. So this is how I got a solution of V1 V2. Now the question again arises that you can see the solutions also. So the same thing I have done in this numerical with the equation 1 and 2, and here also we just find out and solve it, this equation 2, and again we get this to addition and we get 2V1 minus V2 equals to minus 20, and also we get here by multiplying this 2 here and try to solve the equation 3 and 4. What we get finally is V1 is equal to minus this minus 7.33 volts, and V2 is minus 5.334 volts, and this is what we obtained by using the node analysis. Now can we use a mesh analysis and find out the same? So let us try with the mesh analysis. So what we were going to do is we try to apply the mesh analysis in the same numerical and try to find out the solution. So in order to find a mesh analysis, let us take the mesh over here, because this is one mesh, and let me write here I1 as a current in the mesh 1, and let me write here I2 as a current in mesh 2, and let me write here I3 as a current in mesh 3, and here the current in mesh 4 is I4. The good thing about this is that I1 and I3 I can find immediately in mesh. So we just write on mesh 1, because I1 current in the branch, there is a current source, and this current cannot be anything else, so it must be having 5 amperes. So we can write mesh 1 from there. We can simply write I1 is equal to 5 ampere. Also we can write from mesh 3 directly that mesh 3, we can simply write in from mesh 3 that I3 is equals to 10 ampere, because my direction of the assumed current is top to bottom here, and the current which is flowing in this branch is 10 ampere top to bottom. So these two, okay, satisfy, easily find out. Again, I just need to find out the mesh current over here. So here, if I am moving in this direction, so let us go write for equation for mesh 3. Equation for mesh 2. So in mesh 2, if I write like this, so first because I am moving in this direction, so all my sign convention will be like this. So here there is no sign required. So here only minus, and here only plus and minus. And this is a voltage source. So if I move from here, I see the plus first. So 2. The current here is like a subtraction, because the current I2 is there and I1 is subtracting, so I can write here I2 minus I1, and then we move again. I saw the first minus, so minus 2. Then I move from here, the first I see that plus sign here, so plus 4. Then I2 minus of I3, because I2 minus of I3, because of this I3 is going opposite to it, and this is equal to 0. So this is what I get from equation mesh 2. And the good thing, see that this I1 is known to you, I3 is known to you, so you can immediately find the value of I2. And if you solve the value of I2 from here, it will come out to be 8.66 ampere. Now you have got another equation for mesh 4. This mesh 4, if you find out this KVL, because when you use a mesh analysis, you are actually using KVL, Kirchhoff's voltage law, and you're moving in this direction. So okay, you got a 8 and multiply with I4, because 8 is only in the mesh 4, and then again you see the plus sign, so plus 2 is equal to 0. So here also you get the value of I4 very easily, and that I4 is coming out to be from here is minus 1/4 amperes. So how I am going to verify? Suppose in the node analysis I verified the value of V1, and so how much was V1? V1, if we find out this value of V1 is equals to minus 7.32 volts. So how to verify from the mesh analysis? So V1 is nothing but the potential across this, we can say. Okay, that V1 is nothing but a potential in this direction, so plus minus over here. So if I say potential across 2 ohms, so 2 multiplied by current is moving downward to be assumed, and this current I2 is moving upward, so it is I1 minus I2. So this is the potential of V1. So let me check here. 2 I1 value will substitute is 5, minus I2 is 8.66. And if I solve this, I'm getting the value of V1 as minus 7.32 volt. So here these two match, and like that we can find the value of V2. So when you find the value of V2, obviously you can see that this, you can take this as like 4, what is the voltage across 4 volts, so 4. I2 is the one, because V2 you are finding now, so you are taking this as plus and minus. So I2 is the one which is you are taking its positive, and I3 is getting subtracted. So 4 I2 value is 8.66 minus of I3 is 10. So here it comes out to be this value is V2 is coming out to be minus of 5.33 volts. So like that, you find that from the mesh analysis, you have solved the value of the currents I1, I2, I3 and I4, and using that you find out what is the potential across this V1 and what is the potential across this by you that find out the value of V2, and that match the value of V2 here, minus 5.334 minus 5.33 around this is, we get a value of V2. Similarly, value of V1 you are getting minus 7.32 around, so minus 7.33. so these decimal values you can get it close if you take all the values up to 3-4 decimals. So these things we are matching and we get the right results. So now we are going to take another problem here and try to solve understand that how we can solve this problem here. And we will try to solve using the node analysis, and the node is considered in the given in the book is like V1, and this is V3 and this is V2. And again let us take the node analysis, start with the node analysis, and let us write the equation for node 1. And when we write the equation for node 1, you assume that all the currents are going out, so we have got 1, 2 and 3, so you have got 3 sum will be there. So the first one is, it is opposing, so it's a minus 1 because our assumed direction is opposite to the direction of the source current, and the current which is moving in the direction, what will be? V1 minus V2 divided by 2. So this will be V1 minus V3 divided by 2. Again there is a current over here, and this current will be V1 minus V2 divided by 5. So V1 minus V2 divided by 5 is equal to 0. So we have got a node analysis, that equation for node 1 by using KCL like this. So similarly, let us write for the node 2, and for the node 2 let us see, this is the node 2 over here, and how many elements are connected? 1, 2, 3. So there are 3 additions possible, and let us assume all are going out. So from V2 to the reference it is coming, so we'll say only V2 by 5, and here from V2 it is coming to V3. Okay, so it is V2 minus V3 by 10, and here from V2 it is coming to V1, so it is V2 minus V1 by 5. This is equal to 0. So we have got 2 equations done for node 1 and node 2. Now we will write for the node 3. So while writing the equation for the node 3, and the good thing about this node 3 is that do I really need to find out the equation for node 3? Because here I cannot find the current, right? Because you cannot find the current here, there is no resistance is there. So there is meaningless to add in 3 currents. Another good thing is that this is not the good thing, that current is not there, but the plus point is that you have got a voltage source between the V3 and reference. So directly we can write here V3 is equals to 10. So we get the value of V3 directly here, and so we have got equation 1, equation 2 and equation 3, and take the value of V3 and substitute over here. So we can rewrite the equation 1, rewrite the equation 2, and just substitute the value of V3 in equation 1 and 2, and after substituting we can get the final value. So if I rewrite this equation 1, what I am going to get is 7V1 minus 2V2 minus 5V3 is equals to 10. Rewriting this again, we will get 5V2 minus 2V1 minus V3 is equals to 0, and substituting the value of V3 over here and solving this, what we are going to get finally is V1 is equals to 10.32 volts and V2 is equals to 6.129 volts. So that's what the value of V1 and V2 we get. So here V1 value we get is 10.32 volts, and here V2 value is 6.129 volts. So you get the values of these node voltages by using node analysis simply by putting like this. So now our objective is to see that can we get the same value if we use the mesh analysis in the same equation. So here we have another equation. So what we are going to do is we will not use the node analysis, rather we are going to use the mesh analysis, and we are going to write here that using mesh analysis if we can solve it or not. So let us take the mesh, means let us take a current all clockwise here I1, and another mesh we take the I2, another mesh we will take is that I3, and all are like clockwise. So by using a mesh analysis we are trying to solve again. So using a mesh analysis, so mesh at mesh 1, so in the first mesh applying the KVL, Kirchhoff's voltage law. So our assumed direction like this, but the good point what we see here is I do not need to go for like KVL here, because in this mesh there is a current source. So the wire, in this wire, whatever the current will flow, that is the I1, and that is also 1 ampere. So directly I can write I1 is equal to 1 ampere. I got the value of I1 directly. So from mesh 2, what we can do is in the mesh 2 we have to apply the KVL. So first I encounter the minus sign. So all the time I will get the same plus and minus, because I assumed in the clockwise. So first is minus 10, then I find here plus, then write down the 10. This 10 ohm resistor, there is two currents are flowing. One current is I2, which is moving from left to right. Another current is moving from right to left, that is I3. So better write I2 minus I3. Then you have got a 5 ohm, this 5 ohm, and the good thing is that in 5 ohm only one current is there, I2, which is moving from top to bottom, and this is equal to 0. So you have got a second equation done. So you have got two equations. Now you have got mesh 3. So mesh 3 is over here. So mesh 3, you can see that you are making a clockwise symbol. So if whatever there is a sign convention, that will all come in a plus minus. Like if for mesh 3 everything is positive. So when you move, let us move from here. So there's a 5, and whatever the current is, only one current it is there because it is in one mesh. Then you have a 10. So you have got 10 I3 minus, which is the current which is opposing, is that I2. And again you have got 2. What is the current is I3, and whatever is opposing is I1 is equal to 0. So like that you have got 3 equations done. So once you have got the value of I1 done here, from this equation you can get back to the easier equations. So if we just solve this equation, so from 2 what we can get is 15 I2 minus 10 I3 is equals to 10. So this is what we get from mesh 2. So can we just see the mesh 2 again? This is mesh 2. So I'm getting a trick over here. In the trick you can say in mesh 2 how many resistance are there in mesh 2, like 10 plus 5, 15. So directly you can write 15 I2. And which mesh this mesh 2 is shared with? Is shared with the 3, and which resistance? 10. So minus 10 I3. And the voltage which is encountered is a minus 10. It will come on right hand side, it will 10. So like that you can write easily directly also by the time you practice. And here you're getting the, if after solving this you will getting minus 10 I2 plus 17 I3 is equals to 2. After substituting the value of I1 you get this equation. So you have got 2 variables and 2 equations, and by solving it you will get the value of I2. You will get the value of I2 here. I2 is equals to 1.2258 ampere, and I3 is equals to 0.8387 ampere, and like that. And you don't have to find the value of I1 because I1 is already 1 ampere known. Now the point is that you need to find what is the value of V2 from here. So V2 is nothing but, you can say V2 is nothing but, it is just a 5 into I2. 5 into I2. If you can just find out the 5 into I2, this comes around 6.129 volt. Let us check if it's 6.129 volts. 6.129 volts. See, that is the value of the V2 over here by using node analysis, and we are getting the same value by using the mesh analysis. So like that, you can also verify the values of V1, V3 is not to be, it's like 10. So this way also you can solve by using, and you can verify within the another analysis like mesh and node analysis. So let us take another problem over here, and this is in this problem it has been asked that solve using the mesh analysis. So this is different from the other problem, is that there is a dependent source voltage, dependent voltage source is there whose value is 30 I1, and this I1 is nothing but the mesh current I1 here. So I can say 30 I1 is also the current which is going from this like 10 ohm, because this I1 is flowing from 10 ohm, so we can also say in that way. So if there is a dependent voltage source, no need to worry about, just simply apply the mesh analysis, and in the mesh analysis we'll apply the KVL. So applying KVL, you can write like this, applying KVL in mesh 1, we can write like that. And in mesh 1, so you can see first is minus sign over here, so minus 50. So what you get is minus 50, then you get plus 10, it is only with I1, then you get 20, that is 20 with only multiply with I1, then you get 10 here, but this 10 is not with only I1, rather it is I1 minus I2, then you get minus of that, whatever the value is, simply write that minus of 30 I1 is equal to 0. So you get a long equation like this. So if you're getting a very smart nowadays, like you can simply rewrite this not by adding like this. From C again you can write like minus 50, because your minus is encountered first, then you just move on here 10, 20, 10, how much it is? 20, 30, 40. So simply write 40 I1, and you'll find that this 10 is sharing with another mesh, so it is the opposite definitely current, because you are choosing clockwise in both. So this is minus 10 I2, and you get this sign is you have to consider minus 30 I1 is equal to 0. So this is quicker way of like solving the mesh equation. So another equation for mesh 2 you can have, in mesh 2 you have got you again move from in the clockwise, so plus minus, so again plus minus over here, and let us begin with. So you have got 30 I1, that is a voltage source, but it is dependent source, but no doubt, but you just take it as a voltage source 30 I1, then here plus 10 I2 minus of I1, then you get here 5, then 5 I2, then you again get a voltage source with 10 is equal to 0. So now you have got two equations done here, 1 and equation 2. If you have two equations now and you've got to solve this, finally what you're going to get is here the value of I1 is equals to 13 by 7 or 1.857 amperes, and you got the value of I2 is equal to minus 22 by 7 or is equal to minus 3.1428 amperes. So you get the value of I1 this much and I2 this much. So now we are going to use the node analysis to solve the problem and see that our value of I1 I2 coming same or different. So we have got the same problem over here, but this time in this problem, though it has been asked about to solve by using mesh analysis, but we try to solve using a node analysis the same problem. So if I solve the same problem using the node analysis, let us see that what difference makes. So let us make one as a reference, and one, this is we need not to just worry about, because we have got only one node over two nodes over here. One is a reference and one node over here. So this type of problem is if you usually solve by using node analysis, it is very easy. So let us try this for node equation for this. So I am writing simply the equation V, one line for this is the current which is going here. So that will nothing but V minus, it is encounter with this 50. So 50 plus sign is on the top, so that's why V minus 50 divided by the total resistance is 30. So this is the thing, and here it is V, because this voltage is like one type of favoring this voltage, favoring the current which is going down. So you can write here V plus 30 I1 divided by 10. 10 is that resistance, and here it is V minus, you can write V minus 10 by 5 is equal to 0. So you have got this one big equation ready for the solution. So if you can solve this, so what you can do is simply take V, take all the coefficients from here, like 1 by 30, 1 by 10, 1 by 5, 1 by 10, 1 by 5, and here you can take out this 50 from this hand side, and you can write like 50 by 30, and you can take another constant on the right hand side, plus 10 by 5. Then you can take this thing also right hand side, it is 30 I1 by 10, and then you can solve it. Now what you can finally get is, you can get V, and this value is 10 by 30 is equals to 110 by 30 plus, why I'm writing is plus, I'm substituting the value of I1 here, so better let me put the value of I1 then right here. So minus of like this 10 and this cancels 3, so the value of I1, so what is the value of I1, how can I write that? So this I1 is the current which is going from this 10 ohm, we can also say, or it is just like for whatever the current which is current which is going from 10 ohm in the upward direction, right? So we know that this is the current which is that coming from V to the downward direction, coming from through 10-1 in the downward direction. So why just you don't take it this as a negative value of it? So it is just a minus of V minus 50 by 30. So if you just take this one out, this minus will get add up, and if you solve this, this will become, so let me just write down this value. This is V 10 by 30 is equals to 110 by 30, and minus this will be plus, this 3 get 10, so it is V minus 50 divided by 10. Now if you're going to solve this, you're going to get V is equals to minus 40 by 7, and this minus 40 by 7 is, now you got the value of V. This is minus 40 by 7 volts. So now once you get the value of V, can I find the value of I1 here? Or the value of I2 here. Let us find the value of I2 here. I2 is the current which is in the mesh, right? So I2 is also the current which is flowing from this 5 ohm. So what is the current which is flowing from the 5 ohm? Is 10 minus, this is the current, right? So I2 is equals to V minus 10 by 5. Substitute the value of V over here, and what you will find is I2 is minus 22 by 7 ampere. So that is how we solved the same problem by using the mesh analysis, and now we solve the same problem by using node analysis, and we get the same answers. So that is how you can practice. Many problems are there, you can practice and get yourself more confident on mesh analysis and node analysis. Thank you very much. All the best.